Hey, Coaster 101, it's Nick, and I'm back here with my 3D CAD roller coaster model. Last time I showed you how to make what we've got on the screen here. Just a quick one way to make a roller coaster in a 3D CAD program, but our coaster track is parallel to the ground the whole way. So in this video, I'm just going to show you how to angle the track using the same method we used before with these law commands. Maybe it's a little hard to see that there's no banking. Maybe it would be easier if we added like a ground. So we'll just pick 0, 0, 0. Here's a top view. Maybe if we just make a big rectangle. And we'll just fill that in. Let's make it green like it's grass or something really bright grass. Does that help? It's kind of help. See, although our track is right on the ground there. Okay, there we go. It's quite a bit lower, but that's fine. Alright, so how do we bank this thing? Sketch here. Alright, so there's my lines. And I could have, instead of making lines, I could have just done like planes in 3D instead of a 2D sketch, but oh well. Alright, so coming out of the station and going up the lift, we want it to be flat, so we're going to be at 0 degrees. We want to go a little bit beyond the top of the lift here because this part's flat. Then we want to bank up to 45. And then we're going to come back down. So to get 45 degrees, we're going to change the height of this to 45. And I want the sphere banking to be approximately halfway between the top of the lift and the bottom of the first drop. So top of the bunny hill, bottom of the bunny hill, we'll keep flat. We'll do another little hill. Or bank on the last curve, and then going into the station we want that to be flat or 0 banking. So I'm going to coincidence this. Again, we will make this 45. It doesn't screw it up too much. Where's the point? Move that over. I want the apex to be at the top height of there. Alright. So it's hard to see, but it should be banked to one side, banked to the other side. Let's see if this works. If you can't tell, I have not practiced or prepared or planned out any of this in advance. I'm just making this all up as we go. Alright, so reference, this axis, definition, this curve. We're going to make the law just like we did before. Hopefully this works. So now we will find our sweep that we made last time. So here for the angle, right now it's 0. I mean, you could make the whole thing at an angle if you wanted to. That doesn't do much for you. So what we'll do instead is we will use a law. And we will select this law so you can see here up to 45, down to 45. And oops, it looks like I went. It looks like it banks the wrong way than what I intended. So we do inverse, we just flip it. There we go. So now we update, the rails should match that banking. And now we got some messed up banking for you. So again, it's 0, and it starts banking. And then I actually have an outside bank turn at the end here. Alright, so at this point you may be sitting there thinking, why would you build a roller coaster using this method? Well, one possible reason for designing the banking in a 2D sketch is so that you can easily check the degree of roll per foot. So what do I mean by that? When designing the layout, the track can only twist or roll or bank a certain amount over a specified distance. And that is limited by the amount of articulation between axles on the vehicle. So the amount the track can twist or bank between 2 points is limited by the design of the vehicles, how much the axles can move with or rotate with respect to one another. Now on Holiday World's YouTube channel, there is an excellent video of the late Will Cook explaining how when they moved cars from the Raven roller coaster over to the Voyage, they had to modify the cars because the track on the Voyage can twist more per foot than the Raven could. So when the banking rate is shown in a 2D chart, like this yellow line, for example, or like how we're sketching in our CAD model, it's easy then to check to make sure that the twist rate or roll rate is feasible, because you can draw a line, and the slope of that line is degrees over the distance. So you can easily check to see if your banking rate is feasible for the ability of the car to negotiate. Now, of course, you'd also have to check the G-forces, how fast you're going through those maneuvers to make sure the G-forces are acceptable to the passengers, but you can at least check the amount of twist will even work for the vehicle as a start. So that's one reason for making the banking in a 2D sketch. Of course, I've never designed a real roller coaster myself, so maybe this is doesn't apply at all, or there's some other methods that are better. So if you have designed a real roller coaster, feel free to tell me how wrong I am in the comments. So if you're looking at it, the transition into the angle is pretty steep here, so you can go in and just make your sketch smoother. You can put some corners on there. So hopefully that'll make the transition a little better. Let's see. There we go. There we go. It's okay. Foggy up there. Should we try baking it more, see what happens? So this first one, move the whole thing. Can I move it over more? Something like that. Now can I make the airtime hill? So we have lift, drop. Can we make the airtime hill have a little bit of a off-axis movement here? Just try this as an experiment. Say like 25. Not lining up on the top of the hill, but there's a little bank in the track there. There's a terrible transition right there. But anyways, you get the idea. So you can use another sketch where the center line is 0 degrees and you go up and down to bank right or left. So you can use another 2D sketch to control a 3D shape. So now another question is cross ties. How do you do cross ties? Well, there is not a really good or easy way that I know how to do cross ties in CATIA. Because normally you would think you'd just draw a sketch. Well, here, let's do that. Well, first let's change, I'm going to change the rails. So right now I did this RMC style, even though, you know, RMC's Iron Horse track is not just one singular like extrusion piece like this. It's multiple pieces put together, of course, made from, you know, like single sheets of steel, bolted and welded together. And also, so I have this center line here. When really, like, if the center line is the heart line of the passengers, it's going to be approximately where, you know, where the passenger's heart is. So that in reality would be like maybe 3 feet above the rails. So, oops. I go to my rail sketch. If this was a true heart line, then let's see if I can move these. The rails would be more like down here. So if I updated this, it would look more like that, where the heart line is above the rails, approximately where the passengers are sitting. So now it would kind of and see how the rails then twists around the heart line. But for this purpose, just to show you some thoughts on the cross ties, I'm going to change the rail style to just your typical round steel tube rails. And I'm just going to put them in line with the heart line just to make the sketches easier here. So if I update, it should change. Now we have just tubes. I think the RMC track look cooler. Oh, these look kind of small. Maybe I just need to increase the size a little bit. you know, I'm working in millimeters right now, so it's hard to visualize millimeters compared to like inches or feet for us Americans here. Okay, so just do a plain, boring, round cross tie. You could just make a sketch like this. And boom. There's your cross tie. I'm going to change the color to, let's do yellow, because in CATIA red means you need to update, so it always throws me off to see it in red. I always do light blue. So there's a simple cross tie, but in CATIA there's not an easy way that I know how to do this, because you have pattern, which can be in a straight line or a circle or a user pattern, but the user pattern's not going to follow a surface. Here, let's try to do an example of that. So let's say we want to put a cross tie, a series of points. So I can go over here, do points repetition. So first point, and do my start curve here. I want to say spacing. So if I do every 100 millimeters, let's just double that. Alright, so now I have all these points along the center line. So let's say I wanted to pattern this on every point. You can go to, we got pad, positions are going to be Where's my points? Okay. So it looks like there's 154. So up the lift looks okay. But then when you start adding banking and turns, then it's not following the curve of the rails. These cross ties get screwed up. So there's different ways you could fix this. I'm not going to go out into them in this video. There's power copy, and there's writing a macro and other things. I can show you, if you've ever seen my cantilevered coaster models, which are on YouTube. There's 2 tracks, and you can see there's cross ties evenly spaced. So I can tell you that these cross ties were created using a macro. So there's basically 2 guide curves along each of the rails, and that's how it makes the cross ties, which getting into making macros is a whole nother story altogether. Maybe let's talk about some other time, not in this video, but I just wanted to show you this clip to show you it is possible to easily make cross ties pretty much instantly when you run a macro, so that you don't have to model everyone individually. And that cantilevered coaster model is using the kinematics workbench. So this video has probably gone on about long enough. Maybe I'll just quickly show you just a simple supports. head layout, center head line. So I've projected the center line onto this surface. I drew a circle for the support. I'm going to do my user pattern. And select all the points. So it's going to put the circle at all those points. Now I can say up to surface, select our sweep, and where'd they go? Here they are. Alright, and there it made some supports for us. It's the funky minus the funky cross ties and the weird banking. There you have a roller coaster. At least it kind of looks like one. Would I model a real roller coaster like this? Probably not, but this was again just a demonstration, show you quickly one way to do it, teach you a couple different functions in CAD, and hopefully get you thinking about different ways that you could design a roller coaster. So I hope you enjoyed these series of videos. If you have any questions or comments, please let me know in the comments below. And thanks for watching.